Good day, math learners. I'm back. In this topic, I will discuss about scientific notation. Did you know that very large and very small numbers or measurement, like millions or decimal numbers, are very tedious to write, difficult to read, and hard to compute. But these numbers can be written more conveniently using the scientific notation. And that's the use of the scientific notation. That will be our discussion for today. Did you know that the mass of the sun is about 2 million, billion, trillion? Mm-hmm. That's the use of scientific notation. Maybe no or maybe yes, you cannot read that number because it is very large number. But with the use of scientific notation, we can make it into a smaller number. So we will just, can you count the numbers or can you count the zeros for that number? So 1, 2, 3, 4, 5, 6, 9, 12, 15, 18, 21, 24, 27, 30. So it have 30 zeros. That's why 2 times 10 raised to 30 kilograms. Because we're talking about mass, that's why kilograms. Can you imagine how heavy that is? Remember that the average weight of an adult is 60 kilograms. Will all the people in the world weigh anywhere near the weight of the sun? It's just small pieces if we are near to the sun, like this, like a dust or a dot. So, scientific notation is a concise way of expressing very large number or very small numbers. A positive number is written in scientific notation if it is in the form a times 10 raised to n, where 1 is greater than or equal to a greater than or equal to 10, and n is an integer. There are steps on how to change numbers from standard form to scientific notation. Step 1. Move the decimal point in the standard form so that the new number has a value between 1 and 10. Step 2. Write the second factor as a power of 10. We will use 10 as our factor. Step 3. Count the number of decimal places the decimal point has moved. Again, the decimal point will move. It's either to the right side or to the left side. This is the exponent to which 10 is raised. So example for the given for the weight of the sun. So that's why it is raised to 30. If the decimal point is moved to the left, the exponent is positive. But if the decimal point is moved to the right, then the exponent is negative. Don't forget the steps in changing numbers from standard form to scientific notation. Example number 1. The given problem, consider the distance between the Sun and the Earth, which is about 150 million kilometers. The distance can be changed into the scientific notation. From that larger number, we can make it into a smaller number. That's the way on how to do the scientific notation, or that's the use of scientific notation from larger number to smaller number. To change the distance between the Sun and Earth into scientific notation, we must follow the steps. First step is the given number, which is 150 million kilometers. Second step, move the decimal point in the standard form so that the new number has a value between 1 and 10. Your final decimal number must be between 1 and 10. So in the given 150 million, we'll start here. The decimal point will be start here. So it will be moved to the, is it left or right? You will move to the left. 1, 2, 3, 4, 5, 6, 7, 8. Because 1 and 5 is between 1 and 10. So we will stop the decimal point from there. So the result is, before that, count the number of the decimal point that is being moved. This is the exponent. The decimal point is moved to the right, to the left, I mean. So the decimal point is moved to the left. Therefore, our exponent is positive. So the result is 1.5 times 10 raised to 8. Why is it is raised to 8? Because we move the decimal point to the right and it is 8 moves. That's why it is raised to 8. Remember, the number should be between 1 and 10. That's why we end the decimal point between 1 and 5. Example number 2. The diameter of a red blood cell is about 0.00075 centimeter. Write the number into scientific notation. The given problem or the given number is 0.0075 centimeter. Second step, move the decimal point in the standard form so that the new number has a value between 1 and 10. We will move the decimal point. Is it either left or right? We will see. So the decimal point. So we will use that decimal point. So we will go on to the, we'll go to the what? We'll go to the right. So the decimal point will move to the right. 1 move. 2 moves. 3, 4. So 4 moves. The decimal point is moved 4 times. So count the number of decimal places the decimal point is moved. This is the exponent to which 10 is raised. If the decimal point is moved to the right, then the exponent is negative. So it has four movements. So it will raise to 4. But because it is moved to the right, the exponent is negative. So the answer is 7.5 times 10 raised to negative 4. Thank you for listening. Don't forget to answer the given formative assessment. We will continue our discussion about scientific notation. Right now, it is the steps in changing numbers from scientific notation to standard form. So, in our discussion, or in our past discussion, it is from standard form to scientific notation. So right now, it is from scientific notation to standard form. Steps in changing numbers from scientific notation to standard form. Step 1. Move the decimal point in the first factor to the number of places indicated by the exponent of the power of 10. Second step. If the exponent is positive, move the decimal point to the right. If the exponent is negative, move the decimal point to the left. Don't forget that. Again, if the exponent is positive, you will move the decimal point to the right. If the exponent is negative, move the exponent, or not, sorry, not the exponent, the decimal point to the left. Yes, to the left. Yes, exactly. Example, 8.51 times 10 raised to 8. The decimal point is coming from 8. Our exponent is positive 8. So it is positive 8. The decimal point will go to the right. So write the number in standard form. So from the given 8.51 times 10 raised to 8, that is in scientific notation, we will do that in standard form. Let's go. You will move the decimal point 8 places because our exponent is 8, and is going to the right because it is positive 8. So you'll move to the right, move 8 times. 1, 2, 3, 4, 5, 6, 7, 8. The decimal point will be put to the last part. So from 8.51 times 10 raised to 8, and that will be equal to 851 million. That's our final answer. Example number 2. Write the number in standard form. The given number 6.65 times 10 raised to negative 5. To solve that in scientific notation, you will move the decimal point 5 times because the exponent is 5. The decimal point will move to the left because our exponent is negative. So we'll move the decimal point 5 times going to the left. 1, 2, 3, 4, 5. And the result is from 6.65 times 10 raised to negative 5 is equal to 0.0000665. And that will be our final answer. Thank you for listening. Don't forget to answer the given formative assessment.